Okay, so our first topic in Unit 4 is about interest in financial terms. Okay, so the way that the world works, most people don't have enough money on hand for large purchases like cars and houses, and often things like college tuition, right? So they need to borrow money. And on the other hand, people who don't have an immediate need to spend their money, rather than their money just sitting around, they can deposit it in a bank. So yeah, borrowing money is not free, right? If a bank is going to lend you money for you to spend, they're going to expect a little bit extra back, right? As a service, basically, service charge for them doing you that favor. Okay, so there's different ways of calculating the cost of interest. There's different sort of systems. The first one is called simple interest. So here's the first formula you'll want to write down. Okay, capital I. So not lowercase I, right? That's imaginary. Capital I is different. Capital I equals capital P, lowercase r, lowercase t. Okay, so capital I represents the interest, which again is the extra amount of money. Just for example, let's say you borrow $100 from a bank, and then the next month you pay them back $107. So you paid $7 extra, so the interest was $7. Okay, capital P represents what's called the principal. So it's spelled like the school official, but in money terms, principal is the sort of the initial or starting amount. Lowercase r represents the interest rate. Okay, so yeah, different banks offer different interest rates. So that's one thing that affects the amount of interest you earn and the amount of interest you get charged when you borrow money. And then lowercase t, for this formula, it's the time in years. Okay, so yeah, interest can be both to your benefit and to your detriment. So yeah, if you deposit money in a bank, they'll likely offer you interest. You gain money, but when you borrow money, then they charge you interest. You have to pay extra when you pay it back. Okay, so okay, find the ending balance. Okay, so balance is another word that you should know. Yeah, balance is, yeah, exactly. So after all the changes have been applied, whether increases or decreases, the balance is the final amount. Okay, so of borrowing $34,100 at 4% annually for 3 years. Okay, so the starting amount, the amount that you initially borrow, is $34,100. Okay, so that will represent the principal. Okay, and then the next thing they tell us is at 4%. So the percentage is your interest rate. Now we do want to convert the percent form to decimal form. Exactly. Remember, percent means per 100. So 4% is 4 out of 100, which is, sorry, that's not right, 0.04. Okay, so there is a little shortcut to convert percent to decimal. If there's a decimal point, great. If not, you put it on the right, like 4 is 4.0. And then when you divide by 100, that's always equivalent to moving the decimal point twice to the left. Okay, so since we have a gap here, that gap is filled in with a 0. Yeah, so yeah, 4% is equal to 0.04 or 0.04 if you want to put the zero before the decimal point. Okay, and then the last piece of information is that the interest builds for 3 years. Okay, so the time is 3, t is 3. Okay, so this first one is, again, simple interest. So we're just going to substitute all the values into this formula. We don't know the interest, so we'll leave that as capital I. But capital P, the principal, 34,100. And then we know when letters touch without symbols, they're multiplying each other. Right, so we multiply that by the decimal form of the interest rate, so times 0.04. And then you also multiply that by the number of years, which here is 3. Okay, so yeah, you'll need a calculator for today. As always, if you need to check one out, I just ask that you drop off your ID or something similar so you remember to return it. Okay, so I equals 4,092. Yep. Exactly, yes. Correct. Good. Beckett correctly noticed that. This is not our final answer. We calculated the interest, the extra amount you have to pay. But the question was, what's the balance? Meaning, like, what's the total amount that you have to pay back? Yeah. Okay. So yeah, in this case, the balance will be the principal plus the interest. Okay, because you still have to pay back the 34,100 you borrowed, but then you also need to pay the extra $4,092 of interest that built up. Okay, so yeah, that'll be a big part of these money problems. Identifying, what part of the problem is being asked for. Some problems will just ask for the interest and you stop here. In this case, you are asked for the balance, so you need to find the total amount. So you still pay the original principal back, but you also pay the extra interest. So you add those together to get the balance. Okay, so go and take a minute and see if you can do problem 2 without me doing it first. Okay, so again, read carefully, make sure you see what is being asked for. Okay, so for this one, the starting amount is $43,800, so that's your principal. The interest rate, this one already has a decimal point, so you move it twice from where it started. You again do have a gap that you need to fill in with a 0. So the interest rate would be 0.048 in decimal form, right? Even though it has a decimal point, it also has a percent sign. So it's not decimal form, it's percent form. So to get rid of the percent sign, you move the decimal twice to the left. Okay, and then the time is 2 years. Okay, so we know the principal, we know the interest rate, and we know the time in years. Okay, so we would just multiply. These are all on the same side of the equal sign, so you just multiply them together. Okay, so now we're dealing with money here. So my calculator says, 4204.8. Yeah, yeah. We would typically go to the second decimal place for money, right? So we can more easily read, oh yeah, it's 80 cents. Okay, and now in the first problem, we added this to the original number because that question asked for the balance. But this question is simply asking for the interest. Okay, so we already have I, the interest. Okay, so this is our final answer already. It would be incorrect if you added it to the 43,800 because that would give you the balance, which is not what was asked for. Okay, so again, this is just one of the sort of methods of calculating interest. Okay, so the problem will have to tell you what type of interest it is. So for these first two problems, I didn't specify because this is the first one we've learned. But yeah, going forward, it'll have to say like simple interest, right? That's how you know to use this formula. Okay, but in the real world, simple interest does exist, but it's not probably the most common type of interest you'll see. So what is a reason for that? Right? So like if a bank is charging you simple interest as what's called an annual rate, annual means once per year. Okay, so if a bank is charging you interest annually, that means when you borrow $100 from them today, they don't get any money until a year from now, until November 14th, 2026. Right? The banks probably don't want to wait that long to earn money, right? That's a long time to go without getting anything back for the money they lent out. Okay, so yeah, as an annual rate, okay. So again, simple interest is not likely the type of interest you'll be dealing with when if you aren't already, start, get your own bank account and you get credit cards and that sort of thing. Okay, so yeah, much more common is what's called compound interest. Okay, so the interest rate will still be given annually, meaning they'll give you a percentage for the year. But instead of waiting until the end of the year to calculate the interest, they can calculate it more frequently. Okay, so this formula is capital A equals capital P, parentheses, 1 plus the fraction R over N, close parentheses, to the power of NT. Okay, so a lot of terms in here. Let's go ahead and define what each of them represent. Okay, so capital A will be the final amount, which again, we can also call the balance. Capital P will be the same thing it was before, which I did in purple. P is again the principal. Okay, lowercase r is still the interest rate. T is still the number of years. Okay, so the new one is n. And you notice that n shows up twice in the formula. So that's how it's supposed to be. So whatever n is, you will place into two different spots in your equation. Okay, so n represents the number of times per year that interest is compounded. Okay, so yeah, it makes a difference how many times the interest is calculated. It's called compound interest because you build interest on your interest, right? So like when you deposit $100 in a bank, if you just get 10% at the end of the year, okay, then 10% of 100, you gain $10. You're at $110 at the end of the year. Okay, let me write this down so it's easier to visualize. Okay, so let's say you deposit $200 and you're not going to get 10% interest rate, by the way. That's a crazy high amount. Or okay, let's do 200. I'm just making the numbers bigger to make the calculation easier. Okay, so in this case, right, you would get 10% of $200 after 1 year. Okay, so you would gain, oh, sorry, where did the 20 come from? That's a 10. Okay, so sorry, let me take a step back because I misspoke. Let's pretend you deposit $200 and you get 10% interest on it for 1 year. Yeah. Okay, so after 1 year, you would have 200 plus 20. You would have $220 total. Okay. Okay. Yeah, but so I was saying that it makes a difference if you compound the interest more often. Okay, so what if you instead you deposit $200, but instead of 10% for 1 year, uh, let's say you get 5% every 6 months. Okay, so it seems like it might be the same, right? If you get in 1 year, this will happen twice, right? So double 5% is 10%. Well, let's see how it makes a difference. Okay, so at the 6 month mark, you get 5% of what you deposited. Okay, so 200 times 0.05. Okay, so that means you gain $10 after the 6 months. Okay, so it still seems like you're gonna get the same amount, right? Because after half a year, you have half as much as before. Okay, but you add that to the principal. Okay, so the key thing to understand is now when you get your second instance of interest, you don't do 5% of 200 again because, yeah, now you have $210. Okay, so you get interest on the extra $10 of the first interest. Okay, so 210 times 0.05. Okay, so your second interest payment is $10.50. Yes, it's not printed on your paper. It's just something I'm adding right now. Yeah, again, these numbers are just made up, but hopefully you see that, yeah, uh, yes, exactly. So yeah, if you compound more often, you get a a bigger balance, a bigger total, because again, you get interest on your interest. Okay, so with that in mind, let's go ahead and do some examples using this formula. Okay, let's say you invest $7,300 at 7% annually, but compounded semi-annually for 3 years. Okay, so our goal is to find the total value, right? So capital A is the unknown, right? We don't know the total value, so that'll be the variable A. You start by investing $7,300, so that's your principal. Okay, one is just one, it's a number, right? It's not a variable. Okay, plus the fraction r over n. So the interest rate is given as 7%, which in decimal form will be 0.07. Okay, and then n, the denominator, is the number of times per year the interest is compounded. So here's a vocab word you'll need to know. Correct, which would mean in a full year it happens twice. Okay, so whenever you see the word semi-annual or semi-annually, that tells you that n is 2. Okay, so like maybe you guys have heard like a semicircle, right? It takes 2 semicircles to make a full circle. Um, okay, and then remember n shows up twice in the formula. So 2 also goes up in the exponent. And in the exponent, it's not just n, it's n multiplied by t. Okay, so t, like before, is the number of years. In this problem, we're told that it's 3. Okay, so the variable is already by itself, which is great, which means that we just need to combine the right side into a single number. Okay, so now you do need to be careful about how you type this into your calculator because depending on what type of calculator you have, you may need an extra set of parentheses. So let me show you an incorrect common mistake. Okay, so when trying to do that calculation above, right? So you say, okay, 7,300 parentheses 1 plus r over n to the power of n times t. Okay, so again, this is it wrong. Okay, this answer is incorrect, right? It's not 23,000.
The one is separate from it.
The one is,
but they're separate from the. It's not that the calculator thinks it's part of the 0.07/2.
Good question. So actually, your calculator does follow order of operations. So it does divide the 0.07 by 2, and it does take that answer plus the 1. So that part was actually fine. The mistake I made was over here when I did my exponent. So we want the 2 times 3 to both be in the exponent, but the way your calculator reads it, it does the exponent of 2 first, and then it takes that whole answer times the 3 afterwards. Okay, we want the 2 times 3 to be calculated first. Okay, so when your exponent has multiple terms, you need to wrap it in parentheses. Okay, so this is the correct value. Okay, and for all money problems, unless otherwise specified, we'll round to the nearest cent. Although you guys may have heard recently that they stopped printing pennies. So yeah, like if you like pay in cash, they'll start like rounding to the nearest 5 cents instead of the nearest cent. But like we know with electronic payments with a credit card, they'll still go to the nearest cent. But yeah, so we'll just round to the second decimal place. So after the 6, the next number is 0 through 4, so we keep it at 6. Okay, so 8,973.56.
You just multiply both of them.
You could do that separately. You could first say, okay, 2 times 3 is 6, and then you just type in 6 as your exponent. For this problem, it's not that bad because 2 and 3 are small numbers. For other problems, the numbers may get bigger. So yeah, however you do it, just make sure that the exponent is calculated first before it's applied to the rest of it.
Any reason why they stopped making pennies?
Yeah, so pennies, the actual metal they use in the penny coins are pretty expensive. They're like, yeah, so they're actually like copper plated. The inside, I believe, is zinc. But yeah, each penny actually costs like 4 cents to make. So yeah, I guess it wasn't worth it to keep making pennies. Okay. So yeah, that's the answer here. Uh, Make sure again you check, is this what was asked for? This question asks for the total value, and A is the final amount, which is the total value. Okay, so yes, that is the answer that was requested. Okay, so some other terms you need to know. Compounded quarterly. So just like there's 4 quarters in a dollar, 4 quarters in a basketball game, quarterly means 4, 4 to make a whole. Okay, so n equals 4 whenever it says compounded quarterly. Um, monthly, right? There's 12 months in a year, so monthly would mean n is 12. All right. Later, you'll see some problems where it's like compounded daily. We would use 365 days per year for that. Okay. But
Scenario with the 50 daily.
um, it, we'll see. It might even be done more often than that, which might seem crazy. But we'll get to that in a few minutes. But yeah, so go ahead and please try the other two problems. So for problem 5, it's actually really 3 problems in one because I asked you to calculate first semi-annually, then quarterly, then monthly. Okay, so yeah, make sure you understand there's 3 different things to do for problem 5. So firstly, problem 4, your principal is just $130. Interest rate is 9.4% in decimal form, will be 0.094. Compounded quarterly, so n is 4, and then the exponent is nt, so 4 times 2. Okay, so this should come out to 156.55. Okay, and you check, right? What do I do with this number? Do I leave it alone? Do I add the original? Do I subtract the original? In this problem, the question is how much money should you get in return? Right? So if you lend out $130, you want the original 130 back plus the interest. Okay, and A, which represents the final, yeah, the A already includes the interest. Okay, so you wouldn't add it to 130 again. You would stop right here. Okay, and then problem 5. I asked you to, I wanted you to start seeing the difference between the different amounts of times per year that you compound the interest. Okay, so for all problems, the principal is 18,000. The interest rate will always be 9%, and the time will always be 6 years. Right? The only difference is going to be the n value. Okay, so first I asked for semi-annually, which means that n is 2. Okay, so if we substitute 2 in for all n's, the final balance comes out to $30,525.87. Okay, so take a step back and think about that. You borrowed 18,000 and you have to pay back over 30 and a half thousand, right? That's how quickly interest can build up. Okay, now what if instead of being compounded semi-annually, it's compounded quarterly? We know that quarterly means n is 4. Okay, so if you do the same calculation but use n is 4 instead, this one would come out to $30,703.80. Okay, and then lastly, what if you compound it monthly? So what if you compound 12 times per year after every single month? Yeah, 1 second. Let me finish this one, then I'll show it again. Okay, so when you use n is 12, this comes out to $30,825.95. Okay, so here they all are again. Okay, so comparing all 3, you see that the more times per year you compound, the higher the balance. Okay, so that means that from the bank's perspective, right, you're working from the bank, you would want the interest to be compounded monthly, right? Because that means that the ending payment is higher. Okay, so exactly, yeah. If you are the one who has to borrow the money, which means you have to pay the interest, then you would want the interest compounded fewer times per year. Okay, so we're going to continue exploring this idea that the more often you compound, the higher the overall value. Okay. Yeah, so yeah, we're going to learn one last type of interest calculation. So this is actually sort of a special case of compound interest, which we just went over. Right, this last one is called continuously compounded interest. Okay, so we know that the word continuous means like it never stops, right? It just keeps going over and over. Okay, so yeah, you could have something called continuously compounded interest, which means that instead of just calculating the interest every year or every 6 months or even every month, uh, it's continuous, meaning like more than a million times per second, which seems crazy, right? Because we just learned that you gain interest on your interest. So wouldn't that mean infinite money if the interest is compounded infinitely? So to understand that, let's go ahead and look at a little, I don't know what you call this, demonstration. Okay, so here, right now, I'm just showing, sorry, I can't really zoom in any more than that. Okay, so right now, I'm just doing compounded annually, right? N is 1. Okay, so I'm not sure if you can see this. I can zoom in a little bit. Okay. So yeah, right now I'm doing, okay, principal is 1,000, interest rate is 5% annually, compounded once per year. Okay, so after 1 year, if it's compounded annually, you get $1,050 as your balance. Okay, so you gain $50 of interest. Okay, so I'm not showing this yet, but next we're going to bump it up to semi-annually. Okay, so everything else stays the same, right? Still 1,000 is your principal, still interest rate of 0.5%. But again, now we're compounding twice per year. Okay, so we're compounding twice as often, right? Instead of once per year, twice per year. Okay, so you might make your prediction. Okay, instead of $50 of interest, how much do you get? Right? Will you get double the interest? Will you get $100 and go up to 1,100? Let's see. Okay, I might need to zoom in a little bit. Okay, so it is more, but if you compound semi-annually, you get $1,050, and let's be generous and round up to 63 cents. Okay, so going from once per year to twice per year, you gained an extra 63 cents of interest. Okay, so now let's do quarterly, 4 times per year. Again, make your prediction on how much extra. Okay, it's, yeah, getting smaller and smaller. So $1,050.95. Okay, let's make a bigger jump. Let's go from quarterly to monthly. Okay, so 3 times more often, right? From 4 times per year to 12 times per year. Okay, so you finally made an extra dollar. But yeah, going from just once a year to 12 times per year only increased your interest from $50 to $51.16. Okay, so let's make a much bigger jump. Let's go from monthly to daily, 365 times per year. Okay, so that's over 30 times more often than monthly, right? 12 times 30 would only be 360. Okay, so 365 should be a lot more, right? Not really. $1,051.27. Okay, so yeah, now let's go really crazy, right? let's compound it 1 million times per year, right? N is 1 million. Okay, so that's way more than daily. Yeah. So I can't even see. Okay, I got to keep zooming. Okay, finally I can see the overlap. Okay, so actually it rounds to the exact same, right? Whether you compound it daily or 1 million times per year, you still get $1,051 and rounds to 27 cents. Okay, so yeah, because the increase is getting smaller and smaller, you can actually compound continuously without it being infinite money. Okay, so that leads us to this thing over here, 1,000 e to the power of 0.05 x. Okay, so you see it basically overlaps the previous number. Okay, so yeah, this number e is probably new to most of us. You may have seen it if you were just looking at your calculator. You do have an e button because it is a very important number. Okay, but yeah, hopefully you understand that. Yeah, interest, even when you compound more often, the amount increases, but by less and less every time. So that's why it's possible to do this thing called continuously compound interest. Okay, so let's go ahead and write down this formula. Okay, so when a problem tells you it's compounded continuously or continuously compounded, right? So the key word you're looking for is continuous. Then you would use this formula. Okay, so again, this formula gives you capital A, and you get that by doing capital P times e to the power of r times t. Okay, let's write this in. Okay, so A stands for the same thing it does before. A is the final amount or the balance. P is also the same thing it was before. P is the principal or the initial amount. R is still the same thing. T is also the same thing. Okay, so the only new part of this formula that we haven't seen before is lowercase e. So e is not a variable. E does not change from problem to problem like x does, right? In one problem, x could be 5. The next problem, x could be 7. E is always the same value, just like pi, right? Pi is always about 3.14. It doesn't change. So yeah, E is a constant. And specifically, E is called, yes, Euler's constant. So yeah, it's not pronounced Euler. It's Euler. Euler's number, actually, I should say, not Euler's constant is what it's more commonly called. Okay, so you don't need to memorize this, but Euler's number is approximately 2.718. All right, so again, pi is about 3.14. Euler's number is about 2.718. Yeah, this guy, Leonhard Euler, he made a lot of mathematical discoveries. So this number was named in his honor. Yeah, so we use lowercase e to represent this. Okay, so let's do an example of this last type of interest calculation, continuously compounded. Okay, so a loan shark, that's basically someone who takes advantage of people in financial need by giving them loans, but at like crazy interest rates. Okay. Yeah, so yeah, the numbers on the front page were saying, oh, like 6% interest, 9% interest. Yeah, so 35% interest, compounded continuously. So there's two separate questions here. How much do they owe after 1 year and how much after 2 years? Okay, so first 1 year. Okay, so we don't know the total amount. That's the unknown. The principal, the initial amount is $1,000. E, remember, is just E. You don't replace E with a number. E is already a number. And in the exponent, we have R times T. So the interest rate, 35%. Here, you don't need to add a zero because there's two digits already. So 0.35 or 0.35. And then times, for this problem, we're first doing T as 1. Okay, so again, your calculator has an E button on it. You just need to find it. For me, it's right above this LN button. You can see this E to the power of X printed in blue. Okay, so I would type in 1000, the principal, and then second that button. Okay, and you notice it does the exponent and parentheses for me. The way the number E works, it pretty much always has an exponent. So that's why your calculator just assumes that you want it to have an exponent. Okay, so up in the exponent was 0.35 times 1. Okay, so A equals 1,419.0, and we'll round to the nearest cent, so 0.07. Okay, so after 1 year, that's how much they owe. Okay, and then the second half of this question is, what about after 2 years instead? Okay, so the principal stays the same, the interest rate stays the same, but instead of T being 1, we'll make T 2. Okay, so after 2 years, the balance would be $2,013.75.
Double the amount.
Exactly. So yeah, after 2 years, if you didn't pay any back in the meantime, we just calculated that the new balance is over double the original amount. So yeah, they're called loan sharks, right? Sharks are predators. They, take advantage. So E is Euler's number. We wrote it down over here. Again, E is similar to pi. E is just a constant. It's worth the same in every problem. So your calculator you'll type in E to your calculator. Okay, I'll show you. It should be in the top left for you, but you need to push the second button. It's above the LN. Okay, so again, let's check. Is this the final answer? The question was, how much do they owe? So yes, they owe the full amount, right? You don't subtract because we don't care about the interest only. We want the full amount. All right, go ahead and try problem 7, please. So we see the keywords compounded continuously. So that's how we know to use this E formula as opposed to the previous one. Okay, so the initial deposit is 2,000, interest rate 6% in decimal form, 0.06. The time is 8 years. Okay, so a lot of you stopped right here.
Okay, so that's the total.
Yeah, so this is the total amount your account is worth now. But the question was, how much does it earn? Right, so like if you, yeah, exactly.
And you get $1,102.
Yeah, so the interest was the extra amount. So the interest is $1,232.15. Okay, so you've seen the three different types of interest one by one. Um, so down below, we have some mixed practice. Okay, so yeah, how do you know which type to use? Yeah, so if you see the word simple, that means use the first one. Now you got to be careful when you see the word compounded because there's two types of compound interest. There's continuously compounded and there's compounded anything else. Okay, so the word continuous is what you're really looking for. Yeah, so simple means the I equals PRT. Compounded continuously is the PERT. Anything else is the P1 plus whatever. Yeah, get the two formulas from the front page. So yeah, go and take a minute and try the mixed practice below, please. Okay. First one, you see the keyword simple. So that means it's the I equals PRT formula. You want to find the interest. You know the principal, you know the interest rate, you know the number of years. Okay, so here you would owe $90 of interest. Yeah. Problem 9, the keyword here is continuously. So that means you use the A equals PE to the power of RT formula. So the initial amount is 40, interest rate 7% is 0.07, time is 2 years. Okay, so this comes out to $46.01. Problem 10. So this is compounded, but not continuously. It's compounded quarterly. So that means you want to use the formula with the parentheses 1 plus. Quarterly means 4 times per year, so n is 4. Okay, problem 11 was probably the trickiest one because, yeah, this is the only one where you were asked to calculate the rate. Okay, so it is simple interest, so it's going to be the I equals PRT formula. I is not 5,500 though, because, yeah, the total amount you paid back was 5,500. That would be A, but this formula does not use A, it uses I. Okay, so you paid 5,500, the principal was 5,000. So the extra, the interest you paid was just 500. Okay, the principal, you started by borrowing 5,000. We don't know R, so leave it as the variable, but we do know the time is 6 years. Okay, so you just need to get the R by itself. So you divide both sides by 5,006, and then make sure you convert it to percent form. Okay, so it'd be 1.6 repeating percent.
1.6 repeating.
Yeah, or 1 2/3% if you want to use a fraction, I guess.
13 is one that's like not like
True. We'll get to that in a second. Compounded daily. Daily, we use 365 as our number of days.
Oh, after 2 years.
Yeah. Okay, so this is where we use the 1 plus r over n formula. Okay, this comes out to $789, excuse me, and 24 cents.
I misread it. I misread it.
Okay, I'm glad you got it right then. Okay, and this last one is we see the continuously, so we know it's the PERT formula. Okay, the principal is 100. The interest rate is 10%. Um, but the time, 2 years and 3 months. Yeah, so 3 months, we know that 1 year is 12 months. So if you were to convert 3 months to years, it'd be 3/12 of a year, which is 0.25 of a year. Okay, but don't forget you had 2 full years and 0.25 of another. Yeah, so 2 years and 3 months is 2.25 years. Okay, and so this last one, I know many of you probably didn't get to it, but I want to go over it together. So this is a real thing. IRA stands for Individual Retirement Account. This is something that you really, really should do. Uh, so, obviously, everyone at some point in their life would like to be able to retire and, live out the rest of their days without having to work anymore. But you can't rely on, what's called like Social Security, money from the government to give you enough money. You need to be saving money on your own. So IRA is a really good way to do that because the money you put into that account, you get to basically get a tax benefit. You don't pay tax on that money. So it benefits you in two ways. You pay less tax right now and you save money for later. Okay, so sorry, this is actually did I change it on your version? It's supposed to be 7,000 per year. Okay. Okay, I forgot to change it on my version. Yeah, it's gone up slowly over the years. But yeah, it's currently 7,000. Yeah, so they actually set a maximum because again, it's so beneficial to you that if you could deposit more, then smart people would. So you really should maximize this out as soon as possible. Okay, so yeah, you can deposit up to 7,000 per year. The current age to receive Social Security benefits from the government is 67 years old. And over the past like 90 years since this has existed, on average, you've gained about 8% interest per year, compounded continuously. Okay, so a common path is you go to college around 18 years old, go to college for 4 years, you graduate around 22, and you get your first full-time job. Okay, so let's say that you make your first $7,000 IRA deposit when you're 22 years old. How much will that be worth when you retire at 67? Okay, so this is compounded continuously. So we're going to use the A equals PE to the power of RT formula. Right, we're trying to find the ending balance. The initial amount, right, you can only deposit $7,000 that first year. E is just E. It's a number, not a variable. Interest rate, again, this is not a number I made up. This is the actual number. It's not guaranteed. Some years it's less, some years it's more, but on average, it's been 8%, which we know is 0.08. But T is not 67. Exactly, because you didn't deposit when you were born, right? You deposited when you got your first job or first full-time job at 22. So yeah, 67 minus 22 means the interest has been building for 45 years. Okay, so I want you guys to practice using your calculator. Go ahead and type this in and see what it turns into. When I first did this, I had to like triple check because I thought, well, that's way too big. But yeah, go and type it in and see what number this turns into. Yep. Yeah.
That is a lot.
Yeah.
Way more than my deposit. I got 26 pointers.
Quadrillion. Okay, well, I'll check. Something went wrong there.
Something must have put like.
Okay. But yeah, guys. So yeah, the $7,000 you deposit when you are 22 years old, that is estimated to be worth over $250,000, $256,000 when you retire. Okay, and again, this is a one-time deposit. Imagine if you also deposit $7,000 when you're 23, when you're 24, when you're 25. That's probably going to be worth $1 million right there. Okay, so now you have to keep in mind that, prices go up over time also, right? A dollar today is worth less than a dollar was 10 years ago. But yeah, this is the power of compound interest. The sooner you start, the more it's worth in the end, right? So yeah, honestly, if you guys take one thing from this class, something with real life relevance, it would be to start saving money early, because hopefully you see the crazy amount of interest that can build up the sooner you get started. Yes, question?
It's telling me right now, is 750.
Yeah.
At 22. 27.
Yeah. Again, this is not guaranteed because it's based on like the stock market, which varies from year to year. Sometimes it's better, sometimes it's worse. But yeah, over the past like 90 years, on average, it's been 88%. So yeah, like all financial advisors recommend really maximizing your IRA or similar. Okay. Um,
A lot of money.